Hello everyone, my name is Kunjan Parmeshwar Shivgunde. Today I am going to teach you the characteristics of DC series motor. So here is the picture of graph of characteristics. So let's get start. The first graph is of torque between torque and armature current. When the torque increases, the armature current also increases. So the graph is of increasing direction. Second one is of speed and armature current. When the speed increases, the armature current decreases. So the relation between speed and armature current is inversely proportional. Third one is of speed and torque. This one is also inversely proportional. When the speed increases, the torque decreases, and when torque increases, speed decreases. So we are going to know how this happens. So let's get started. So the first character is torque and armature current characteristics. In DC series motor, where the field winding is connected in series with the armature, the torque is proportional to the square of the armature current up to magnetic saturation. This means that if you double the armature current, you roughly quadruple the torque. After magnetic saturation, the relation becomes more linear. So in this, when the relation between torque and the armature current is torque is proportional to the square of armature current. So when the torque increases, when the torque doubles, the armature currents get quadruples of its original value. So the graph is increasing type. Second one, speed and armature current characteristics. In the DC series motor, the field winding is in series with the armature. So the fixed field flux is directly proportional to armature current. Therefore, the motor speed is inversely proportional to armature current. If the armature current increases, the speed decreases, and vice versa. No load speed. A DC series motor should never be operated on no load, as it can reach dangerously high speeds due to the low field flux at low armature current. So in this, when the field windings are in the series with the armature, the flux is directly proportional to armature current. The flux is directly proportional to speed also, so that when the speed increases, speed is inversely proportional to armature current. So when the speed increases, armature current get decreased. So the graph is of decreasing type in the picture given above. So the third one is speed and torque characteristics. Torque and speed characteristics describe the relationships between the amount of rotational force torque a motor produces and the speed at which it rotates. In general, there is an inverse relationship. As speed increases, torque decreases, and vice versa. This means that at low speeds, a motor typically delivers high torque, while at high speeds, it produces lower torque. So, it gives the information that when the speed increases, the torque decreases, as there is a inverse relationship between torque and speed. Huh. Rotational force means torque of a motor produce and speed at which it rotates. At a low speed, the motor typically delivers high torque, and while at a high speed, it produces lower torque. So this is about the topic of characteristics of DC series motor, in which we have learned three characteristics: torque and armature current characteristics, second one is speed and armature current characteristics, and third one is speed and torque characteristics. Thank you.